Everybody, I'm Mr. Kelvin from Educare Tanzania. Welcome again into our lecture session. And today we have presentation based on physics solving of the Necta question. Specifically, we are going to look Form 4. But you can be a Form 1, Form 2, Form 3 as well as Form 4. Within our discussion, there are various kind of the question which are based on all levels. There are the question found in level Form 1, level Form 2, level Form 3, as well as level Form 4. So all of you, you are most welcome to our lecture today. And today we are going to look the Necta, Physics Necta Form 4 of the 2010, specifically within the question number 6. So within the question number 6, the question have got various parts, means it have part A, part B, as well as part C. And each part A have got 2 Roman, as you can see, but part B, it is stand alone. It haven't any Roman, but also part C have got 2 Roman. So you are most welcome to our lecture today. As we done always, starting with reading the questions. After that, we are shifting to the solution part, where we can see how we are supposed to provide the response, the correct answers based on the tested questions. So first we will read all the questions before we jump to solution part. And the question number 6, part A, Roman number 1, the question stated that state Ohm's law. So within Roman number 1 of part A of the question number 6, we have to state Ohm's law. After that, Roman number 2, the question stated that explain briefly with aid of a diagram or of a circuit diagram how you will verify Ohm's law in the laboratory. So we have to explain with the aid of a circuit diagram how we will verify Ohm's law. After that, we have part B. And within part B, the question is stated that how would you know when is necessary to recharge an accumulator? You can see that the word accumulator is difficult, but in language of physics, we mean how you will know that a car battery needs to be recharged. Because when we say about accumulator, it is just a car battery, or it is a battery which involve charging and recharging. So that was part B of the question. And on the last part, means part C, it have got 2 Roman, means Roman number 1 and Roman number 2. So Roman number 1 of the question stated that state briefly the variation of the potential of a pear-shaped conductor and the variation of density of the charge. That was part C, Roman number 1. But part C, Roman number 2, the question stated that an electron passes between 2 plates one of which plate A carries a positive charge and other means plate B carrying a negative charge. The question is, what is the effect on the electron? What is the effect on the electron? You have two plates, plate A and plate B. But electron passes within those two plates, means within plate A and within plate B. And plate A carries a positive charge, but plate B carries a negative charge. Then you are being asked, what is the effect on the electron? Those were the questions asked within the question number 6 of the Necta 2010 Form 4. And now let's look on the solution part, in which we can see how, or we can provide the solution which is necessary for that particular kind of the question. But before we go to look on the solution, let's see first know the background of the question, where the question is being constructed, from which level. This will help us to focus much within that particular level and within that particular topic which were being tested. For instance, the question was based on Form 3 and Form 2, and the question comes from the topic of current electricity. It covers mainly three parts, as we see. There is part A, part B, as well as part C. So within Form 2, there is topic of current electricity. Also within Form 4, there is topic of current electricity. So the question was being constructed from all levels, level Form 2 and level Form 4. So after looking on that background, if you are not already studied the topic of current electricity, don't worry. Go to our website channel, Educare Tanzania, subscribe our media. After that, you'll be able to learn various topics, knowledge, questions based on your particular level. This will help you to improve within your academic performance. And after a little bit background, let's jump to part A of the question, where part A of the question, students in first part, they are required to state the Ohm's law. So we have to state Ohm's law, and we say that the current into the bracket capital letter I flowing through a conductor between 2 points, it is directly proportional to the voltage in the bracket capital letter V across the 2 points, provided temperature and other physical constants or other physical conditions are remain constant. So you can state in other way that provided that temperature and other physical conditions remain constant, current flowing through a conductor is directly proportional to the voltage across the 2 points. So you can put it mathematically as it seems The relationship is given by the formula V is equal to IR, where V means voltage or potential difference, I means current, and R means resistance, which is proportionality constant. So this is a simplification of Ohm's law. So when you are being asked to state Ohm's law, you can state and end within the mathematical expression of the law. So this is a mathematical expression of that law. After that, we are having part A, Roman number 2, where we are required to show how we will verify Ohm's law experimentally. With aid of a diagram or a circuit diagram, we have to explain. We say that Ohm's law can be easily verified by the following experiment. Means we can verify the Ohm's law by using a laboratory performed experiment. And the apparatus which are being required to verify this law, we mention them here. So we must have a resistor, we must have ammeter, we must have voltmeter, we must have battery, we must have a plug key, we must have a rheostat. But there is a missing, which we call it a connecting wire. It is necessary. So those are apparatus which are being needed within the laboratory, so as we can verify the Ohm's law. And the circuit diagram or the circuit connection which will help you to verify the Ohm's law is is shown within the slide. So we say you must have a resistor, this one. We must have voltage connected in parallel way with a load or resistor. We must have a battery. We must have a rheostat. Rheostat is for the production of the varying current. But also we must have a plug key, as it's shown with a capital letter K. But we must have ammeter connected in a series with the circuit components. So important thing to know is this: ammeter is always connected in series with the other electrical equipment, but voltmeter, it is connected parallel to the load or to the electrical equipment. And that is the circuit diagram. So let's explain the procedures which can be done so as to verify Ohm's law. We say that initially the key K is closed and the rheostat is adjusted to get the minimum reading in the ammeter and voltmeter. Because resistance will not vary, it is a constant, but we can get the variation of the current together with voltmeter reading by varying the rheostat. So rheostat is a varying resistance, so we're getting reading the value of current as well as the value of the voltage. So initially you have to close your key kama tulivyoona katika circuit. The current in the circuit is increased gradually by moving sliding terminal of the rheostat. During the process, the current flowing in the circuit and the corresponding value of potential difference across resistance wire are recorded. This way, different sets of value, voltage and current are obtained. For each set of value, means value of voltage and value of current, their ratio is being calculated as V over I. It is calculated and its value is R, means a constant resistor. We say that when you calculate the ratio V over I for each case, you will come to notice that it is almost the same. So V over I is equal to R, which is a constant, and we call it a proportionality constant. After that, you have to plot a graph of the current against the potential difference. It will be a straight line. That will be the nature of the graph. This shows that the current is directly proportional to the potential difference, and utakuwa umeverify Ohm's law. After that, we have part B of the question where students were required to explain how would you know when it is necessary to recharge a accumulator. We say that the following are the points on how you could test whether the car battery need recharging. It includes the following. Number one, we say voltage test with a multimeter. You can done a voltage test with a multimeter, and we know a full charged battery will read 12.4 or 12.7 volt. That is the full charged battery. So below that, you will know that your battery needs to be recharged. But remember to put the terminal correct. Number two, we say handling test. We say turn on the car headlight and observe their brightness. If the headlights are dimmer than usual, it indicates a low battery. Start the car and check if the headlights get brighter. If they do, the alternator is working, but the battery may still need recharging. Also, battery health indicator. Many modern car battery have built-in health indicator. This usually a small window of battery that change color based on the battery condition. If you see the green indicate means the battery is in good condition. If you see the black or red means, or it indicates that your battery need to be recharged or replaced. After that, we have part C, where students were required to number one, brief explain the variation of potential difference over the pear-shaped conductor and the variation of density of a charge. And the last one, to state what is the effect on the electron when it passes in plate A, which having a positive charge, and plate B having a negative charge. So we say variation of potential and charge density on pear-shaped conductor. We start with potential variation. We say that the potential of a surface of pear-shaped conductor is uniform. This means that the electric potential is the same at every point on the surface of the conductor. Let's look charge density variation. We say that the charge density variation across the surface of a pear-shaped conductor, the charge density is I at regions with a small radius of curvature, means shaper points, and lower at the region with a large radius curvature, flatter areas. This is because the electric field is stronger at point which a small radius of curvature, leading to high concentration of charge. Now, let's look the effect on an electron between the charged plate. Plate A having a positive charge, but plate B having a negative charge. We say that when an electron passes between two plates, where plate A carries a positive charge and plate B carries a negative charge, the electron being negative charged, as we know electron it is a negative charge, will be attracted toward the positive plate or positive charged plate, which is plate A, and repelled by the negative charged plate, which is plate B. And we say this results in the electron accelerating toward plate A due to the electric field created by the potential difference between the plates. That is the effect which happened to the flow of electron within those two plates. And this marks the end of our today lesson. Thank you for keep watching Educare Tanzania. Have a nice moment. Goodbye.